Good evening, everybody, and welcome to Midnight Math with Abby. I hope this helps you with whatever you're looking for, so without further ado, let's get started. So today we're going to be talking about inverse trigonometric functions. So I'm going to assume that we all know what an inverse function is, but just to jog your memory, let's say that we have f of x equals x squared, so y would equal x squared, and to find the inverse function, you would just switch x and y so that x would equal y squared. So when you're trying to find the inverse trigonometric function, it's the exact same way of thinking. Let's use sine for instance. If you're trying to find the inverse of sine, which is arcsine, of some value or x, let's say that you have arcsine of x equals y, you would just switch the x and y with any other inverse function, so you'd get sine of y equals x. Now that you guys have the basic gist, let's do an example. So let's assume that x equals theta and y equals 1/2. We're going to be looking for sine of theta equals 1/2 or arcsine of 1/2 equals theta. So we're going to draw out our unit circle really quick, and if we look closely, we can see that the y value at angle pi over 6 equals 1/2, and as we all know, the y value is sine, so we can draw the conclusion that theta equals pi over 6. So I'm going to break this down for you guys really quickly because it might be a little confusing. So we're looking for the angle at which sine equals 1/2. So we're looking for when the y value equals 1/2, and since we looked at our unit circle, we know that that angle is pi over 6. These steps in solving this problem can be used for all trigonometric functions: cosine, tangent, cosecant, secant, and cotangent. Just remember this way of solving the problem. So with that in mind, let's go on to another example. So let's say that cosine of theta equals root 3 over 2. So we're looking for theta, which equals arc cosine of root 3 over 2. So if we draw out our unit circle, we can find that the x value is root 3 over 2 at pi over 6. So with using the same problem solving as we did in the first problem, we can determine that theta equals pi over 6. Let's go on to another example. Let's say we're looking for arctangent of -1. So if we draw out our unit circle, we have to find where sine over cosine or y over x equals -1. So as we can see at negative pi over 4, the values of x and y are root 2 over 2 and negative root 2 over 2. So if we solve that out by using sine over cosine, it equals -1. And from that we can deduce that theta equals negative pi over 4. Okay, hold on, we gotta stop and rewind a bit. Because in that last problem, we could have found another value of theta which would have given us the same answer. So we could have gotten tangent of 3 pi over 4 equals -1 because it still would have been right. Or we could have gotten tangent of 7 pi over 4 equals -1. Why did it have to be negative, and why couldn't we have used that other value? This begs the questions, why can there only be one answer, and how do you know which answer to use? So to answer some of those questions, we're going to discuss some of the rules of inverse trigonometric functions. We're going to start with sine and cosecant, which normally go hand in hand. And with these two trigonometric functions, the inverses of them can only output values on the right side of the unit circle. So it's the same situation with tangent, whereas the inverse function of tangent can only output values on the right side of the unit circle. With cosine, secant, and cotangent, the inverse trigonometric functions can only output values on the top half of the unit circle. Now, that's a lot of information to grasp all at once, so let's go into a little more detail with sine and cosecant. So, as I just explained, the outputs of arcsine and arccosecant are going to be only on the right side of the unit circle, so that means that the left side is completely danger zone. We don't want to go past pi over 2 or past negative pi over 2, so that means we can't go around. And in the example before, I had to do negative pi over 4 because we couldn't go all the way around to get to 7 pi over 4. So that means that the domain for cosecant, sine, and tangent would be negative pi over 2 to pi over 2 with a hole at 0 for cosecant. And for cosine, secant, and cotangent, the domain would be 0 to pi, with a hole at pi over 2 for secant. As you can see, I've drawn out the different danger zones for each inverse trig function. With that new information, let's do another example. We're looking for arc cosecant of root 2, and as we already know, cosecant equals 1 over sine. So we're looking for the values of theta where sine equals root 2 over 2. And in that situation, theta would have two solutions at pi over 4 and 5 pi over 4. But as we just learned, we can only have inverse values of cosecant on the right side of the unit circle. So the only answer would be theta equals pi over 4. We've just covered the basics of inverse trigonometric functions. I hope this has helped you with whatever you were looking for. Good night and good luck. This has been Midnight Math with Abby.